Good morning friends, I am Chetan Dhajaya, Assistant Professor at SMC College of Dairy Science and Content Writer for Paper 12, Module 10, Structure and Properties of Plastics. In this module, we will discuss about different types of plastics, their properties, characteristics and their application in the food systems. Polyethylene. Polyethylene is structurally the simplest plastic and made by addition polymerization of ethylene gas at high temperature and pressure reactors. Low, medium and high density resins are produced depending on the conditions such as temperature, pressure and catalyst of polymerization. The processing conditions control the degree of branching in the polymer chain and therefore the density and other properties of films and other types of packaging. Polyethylenes are readily heat sealable and they can be made into strong and tough films with a good moisture and water vapor barrier properties. They are not high barrier to oils and fats or gases such as carbon dioxide and oxygen compared with other plastics. Although barrier properties increase with density and the heat resistance is lower than that of other plastics used in packaging with a melting point of around 120 degrees Celsius. The melting point increases as the density increases. Polyethylene was first used as an insulator in the 1940s. Polyethylene films are highly susceptible of generating a static charge and need to have anti-static slip agents and anti-blocking compounds added to the resin to assist film manufacturing, conversion and use. It is the most widely used and is cost effective. One of the polyethylene is LDPE, low density polyethylene. LDPE is easily extruded as a tube and blown to stretch it by a factor of 3 times the original area. It is commonly manufactured around 30 micron within a density range 0.91 to 0.925 gram per centimeter cube. The films can be colored by blending pigments with the polymer prior to extrusion, where extruders have more than one dye. 2 or more layers of the same material or co-extruded films comprised of layers of plastic can be produced. With 3 extruders, it is possible to produce a film where a moisture sensitive polymer ethyl vinyl alcohol is sandwiched between protective layers of polyethylene. Ethyl vinyl alcohol provides a gas and odor barrier and polyethylene offers good heat sealing properties and a substrate for printing. Polyethylene films melt at relatively low temperature and welds to itself when cut with a hot wire or blade to form effective seals. For packaging, it is possible to use either pre-made bags or the form fill seal machines using flat film in a real form. A major use of white pigmented LDPE film is for making bags for holding frozen vegetables. By laminating to other substrates with adhesives or extruding the PE polymer onto another material or web, it is possible to make strong sachet, pouches and bags with good seal integrity. As the PE flows to fill holes in the sealing area or around contaminants in the seal. Linear low density polyethylene or LLDPE. LLDPE film has a density range similar to that of LDPE. It has short side chain branching and is superior to LDPE in most properties such as tensile and impact strength and also in puncture resistance. A major use has been the pillow pack for liquid milk and other liquid foods. Medium density polyethylene or MDPE. MDPE film is mechanically stronger than LDPE and therefore used in more demanding situations. LDPE is co-extruded with MDPE to combine the good sealability of LDPE with the toughness and puncture resistance of NDPE. For example, the inner extrusion coating of sachet for dehydrated soup mixes. High density polyethylene or HDPE. HDPE is the toughest grade and is extruded in the thinnest gauges. This film is used for boil in the bag applications, and to improve the heat solubility, HDPE can be co-extruded with LDPE to achieve peelable seals where the polymer layers can be made to separate easily at the interface of the co-extrusion. HDPE film is available with either TD monoaxial orientation or biaxial orientation. HDPE is injection molded for closures, crates, pallets and drums, and rotationally molded for intermediate bulk containers. A major application of HDPE is for blow molded milk containers with a capacity 0.5 to 3 liters. Now, polypropylene. Polypropylene is an additional polymer of propylene formed under heat and pressure using Ziegler-Natta type catalysts to produce a linear polymer. Polypropylene is a harder and denser resin than polyethylene and more transparent in its natural form. The usage of polypropylene developed from the 1950s onwards. PP is the lowest density and highest melting point of all the high volume usage thermoplastics and has a relatively low cost. It can be processed in many ways and has many food packaging applications in both flexible film and rigid form. The high melting point of polypropylene, which is around 160 degrees Celsius, makes it suitable for applications where thermal resistance is needed. For example, in hot filling and microwave packaging. Polypropylene may be extrusion laminated to PET or other high temperature resistance films to produce heat sealable webs which can withstand temperatures up to 115 to 130 degrees Celsius for sterilization and use in retort pouches. Polypropylene is chemically inert and resistant to most commonly found chemicals, both organic and inorganic. It is a barrier to water vapor and has oil and fat resistance. Orientation increases the versatility of polypropylene. Oriented polypropylene or biaxially oriented polypropylene film was the first plastic film to successfully replace regenerated cellulose film in major packaging applications such as biscuit packing. Acrylic coated oriented polypropylene has good runnability including heat sealing on packing machines designed for regenerated cellulose film, though improved temperature control of the heat sealing equipment is required. Oriented polypropylene film is produced in the width of up to 10 meters or more to achieve cost effective production. The limiting factors in production are either extrusion capacity for the thicker films or winding speed of the very thin films. The range of good products packed in polypropylene films include biscuits, chips, snack foods, chocolate, sugar confectionery, ice cream and frozen foods, tea and coffee, etc. Metallized polypropylene film can be used for snacks and chips, and longer shelf life is required. Paperboard can be extrusion coated with polypropylene for use as frozen or chilled food trays, which can be heated in microwave and steam heated ovens. Major food applications of polypropylene are for injection molded pots and tubs for yogurt, ice cream, butter and margarine. It is also blow molded for bottles and wide mouth jars. Polypropylene is widely used for the injection molding of closures for bottles and jars. Now, polyethylene terephthalate or PET. When terephthalate acid reacts with ethylene glycol and polymerizes, the result is PET. PET can be made into films by blowing or casting. It can be blow molded, injection molded, formed, extrusion coated on paperboard and extruded as a sheet for thermoforming. PET can be made into a biaxially oriented range for clear polyester films produced on essentially the same type of extrusion and stentage orienting equipment as oriented polypropylene. Film thickness range from thinner than 12 micron for most polyester films to around 200 micron for laminated composites. PET melts at 260 degrees Celsius and due to the manufacturing condition does not shrink below 180 degrees Celsius. Therefore, PET is ideal for high temperature applications using steam sterilization, boil in the bag and for cooking or reheating in microwave or conventional radiant heat ovens. The film is also flexible in extremes of cold such as -100 degrees Celsius. Heat sealable versions are also available and it can also be laminated to polyethylene to give good heat sealing properties. Coating with PVDC give a good gas barrier and heat sealing capability. PET is a medium oxygen barrier, but becomes a high barrier to oxygen and water vapor when metallized with aluminum. This is used for vacuumized coffee and bag in box liquids, where it is laminated with EVA on both sides to produce highly effective seals. It is also used in snack foods flexible packaging for products with a high fat content requiring barrier to oxygen and UV light. Metallized PET either as a strip or as a flexible laminate is used as a susceptor in microwavable packaging. Reverse printed PET film is used as external ply on FFS pouches, where it provides a heat resistant surface for contact with heat sealing bars. The amorphous cast grades can be used as the bottom web in formed applications which are leaded with a heat sealable grade for PET. These packs can be reheated in microwave and conventional ovens. PET film is also used as outer reverse printed ply in retort pouches, providing strength and puncture resistance, where it is laminated in aluminum foil and either PP or HDPE. PET can be excite coated with silica to improve the barrier while remaining transparent, retortable and microwavable. PET is the fastest growing plastic for packaging applications as a result of its use in for all sizes of carbonated soft drinks and mineral water bottles which are produced by injection stretch blow molding. And PET bottles are also used for edible oils as an alternative to PVC. Polycarbonate. Polycarbonate is a polyester with carbonate in the structure. It is glass clear, very tough and high heat resistance and very durable. It is generally used with returnable bottles of 3 to 6 liters of water or in baby foods, and where high heat resistance is required. Ionomers. Ionomers are polymers formed from metallic salts of acid copolymers and possess interchange ionic cross-link which provide the characteristic properties of the family of plastics. The metallic ions can be zinc or sodium, and the copolymer is based on ethylene and metaacrylic acid. It is clear and tougher than polyethylene, having high puncture strength and has excellent oil and fat resistance. Hence, it is used for the packaging of products contain essential oils, in the aseptic liquid packaging of fruit juices in cartons, and fat products such as snack foods in sachets. It has excellent heat sealing properties leading to increased packing line speeds. It is used in packaging of meat, poultry and cheese. It is particularly useful in packing products with sharp protrusions. In food packaging, ionomer films are used in laminations and extrusion coatings in all the main types of flexible packaging, including vertical and horizontal form fill seal machines, vacuum packaging, modified atmospheric packaging, 4-side sealed pouches and twin web pouches with one web thermoformed. Inner ply of paperboard composite cans can also be used. Diaphragm or membrane seals. Ionomers are used in laminated and coated form with PET, polyamide, polypropylene, polyethylene, aluminum foil, paper and paperboard. Ethyl vinyl acetate or EVA. EVA is a copolymer of ethylene with vinyl acetate. It is similar to polyethylene in many respects, and it is used and blended with polyethylene in several ways. The properties of the blend depend on the proportion of vinyl acetate component. Generally, as the VA component increases, sealing temperature decreases and impact strength and low temperature flexibility, stress resistance and clarity increases. At a 4% level, it improves heat solubility. At 8% level, it increases toughness and elasticity along with improved heat solubility. And at a higher levels, the resultant film has good stretch wrapping properties. EVA with PVDC is a tough high barrier film which is used in vacuum packing of large meat cuts with metallized PET in bag in box liners for wines, etc. Modified EVAs are available for use as peelable coatings on leading materials such as aluminum foil, oriented polypropylene, oriented polyethylene terephthalate and paper. They enable heat sealing, resulting in controllable heat seal strength for easy and clean peeling. These coatings which seal to both flexible and rigid polyethylene, polypropylene, polyethylene terephthalate, polystyrene and polyvinyl chloride containers. Modified EVAs are also used to create strong interlayer tie bonding between dissimilar materials, e.g. between PET and paper, LDPE and ethyl vinyl alcohol, etc. EVA is also a major component of hot melt adhesives frequently used in packaging machinery to erect and close packs such as folding cartons and corrugated packaging. Polyamide. Polyamide are commonly known as nylon. They were initially used in textiles, but subsequently other important applications were developed, including use in packaging and engineering. Polyamide plastics are formed by a condensation reaction between a diamine and a diacid, or a compound containing each functional group. The different types of polyamide plastics are characterized by a number which relates to the number of carbon atoms in the originating monomer. It has mechanical and thermal properties similar to that of PET and therefore similar applications. Polyamide resins can be used to make blown film and they can be co-extruded. Polyamide can be blended with polyethylene, PET, ethyl vinyl acetate and ethyl vinyl alcohol. It can be blow molded to make bottles and jars which are glass clear, low in weight and have a good resistance to impact. Biaxially oriented polyamide film has high heat resistance and excellent resistance to stress cracking and puncture. It has good clarity and is easily thermoformed, giving a relatively deep draw. It provides a good flavor and odor barrier and is resistant to oil and fat. It has a high permeability to moisture vapor and is difficult to heat seal. These features can be overcome by PVDC coating and they can also be overcome by lamination or co-extrusion with polyethylene. And this structure is used as bottom thermoformable web for packing bacon and cheese in vacuum packs or in glass flushed packs, and the film can also be metallized. Polyamide film is used in retortable packaging structures such as polyamide, aluminum foil and PP. This film is non-whitening in retort processing and polyamide is relatively expensive compared to polyethylene, but as it has superior properties, it is effective at low thicknesses also. Polyvinyl chloride or PVC. If one of the hydrogen atoms in ethylene is replaced with chlorine atom, the resultant molecule is called vinyl chloride monomer. In addition, polymerization of vinyl chloride produces polyvinyl chloride or PVC. Rigid unplasticized PVC is used for transparent or colored compartment trays for chocolate assortments and biscuits. It is used with modified atmosphere packaging for thermoform trays to pack salads, sandwiches and cooked meats. Most PVC films are produced by extrusion using bubble process and it can be oriented to produce with film with a high degree of shrinkability. Up to 50% shrinkage is possible at quite low temperatures and the film releases the low energy of the commonly used plastic films when it is heat shrunk around products. It is plasticized and the high stretch and cling make it susceptible for overwrapping fresh produce such as apples and meat in rigid trays using semi-automatic and manual methods. Printed PVC film is used for heat shrinkable sleeve labels for plastic and glass containers. It is also used for tamper evident shrink bands. Thick grades are thermoformed to make trays which after filling are lidded with a heat seal compatible top wrap. PVC has excellent resistance to fat and oil. and it is used in the form of blow molded bottles for vegetable oil and fruit drinks. It has good clarity, and as a film it is tough with high elongation, though with relatively low tensile and tear strength. The moisture vapor transmission rate is relatively high, though adequate for packaging of mineral water, of fruit juice and fruit drinks in bottles. PVC softens depending on its composition at relatively low temperatures around 80 to 95 degrees Celsius, and PVC easily seals to itself with heat, but heat sealing with a hot wire has the disadvantage producing HCl gas. The permeability of water vapor and gases depends on the amount of plasticizer used in manufacture. UPVC is a good gas and water vapor barrier, but these properties decrease with increasing plasticizer content. There are grades which are used to wrap fresh meat and fresh produce, where a good barrier to moisture vapor retards weight loss, but the permeability to oxygen allows the product to breathe. This allows fresh meat to retain its red color and products such as fruits, vegetables, salads to stay fresh for longer time. Polyvinylidene chloride or PVDC. PVDC is a copolymer of vinyl chloride and vinylidene chloride. The latter forms when two hydrogen atoms in ethylene are replaced by chlorine atoms. PVDC is heat sealable and is an excellent barrier to water vapor and gases and to fatty and oily products. As a result of high gas and odor barrier, it is used to protect flavor and aroma sensitive foods from loss of flavor and ingress of volatile contaminants. It is also used in flexible packaging in several ways, such as monolayer film, which is a well known application in cryovac range of packaging. This includes poultry packaging, where hot water shrinkable bags are used to achieve a tight wrap around the product. The film can be used in the form of sachet, but is less likely to be cost effective compared to other plastic films, some of which may incorporate PVDC as a coating. An interesting use is as sausage and chop casing. It can be also used in co-extrusions. The PVDC is often used in co-extrusion, where today extruders incorporate 3, 5 or even 7 extrusion layers to meet product protection and packaging machinery needs cost effectiveness. It can also be used as a coatings in either organic solvents or aqueous dispersions to plastic films such as BOPP and PET, to RCF and to paper and paperboard. So, PVDC is a widely used component in packaging of cured meats, cheese, snack foods, tea, coffee and confectionery. It is used in hot filling, retorting, low temperature storage and modified atmosphere packaging, as well as ambient filling and distribution in wide range of pack shapes. Polystyrene is an addition polymer of styrene, a vinyl compound where hydrogen atom is replaced with benzene ring. Polystyrene has many packaging uses and can be extruded as a monolayer plastic film or co-extruded as a thermoformable plastic sheet, injection molded and formed to give a range of pack types. It also copolymerized to extend its properties. It is less well known as an oriented plastic film, though the film has interesting properties. It has high transparency and it is stiff with characteristic wrinkle suggesting freshness and has a deadfold property. The clear film is used for curtain windows and white pigmented film is used for labels. The film is printable and it has low barrier to moisture vapor and common gases, making it suitable for packaging products such as fresh produce which need to breathe. Polystyrene is easily processed by foaming to produce a rigid lightweight material which has good impact protection and thermal insulation properties. It is used in two ways. The blown foam can be extruded as a sheet which can be thermoformed to make trays for meat and fish, egg cartons, a variety of fast food packs such as clam shell shaped container as well as cups and tubs. Thin sheets can be used as a label stock. The foam can also be produced in pellet or bead form which can be molded with heat and pressure. This is known as expanded polystyrene EPS and which can be used as a transit case for fresh fish with thick walls for insulation. The major disadvantage polystyrene is its brittleness. This can be overcome by blending with styrene butadiene copolymer and elastomeric polymer. The blend is known as high impact polystyrene or HIPS. Blending produces a tougher material, it is translucent and is often used in a white pigmented foam. The sheet can be thermoformed for short shelf life dairy products. High impact polystyrene is also used in multi-layer sheet extrusion with a variety of other polymers, each of which contribute to the protection and application needs of the product concerned. Other polymers which may be used in this way with HIPS include PE, PP, PET, PVDC and ethyl alcohol. The food products packed with these materials include dairy products such as cream and yogurt based desserts, UST milk, cheese, butter, margarine, jam, fruit compote, fresh meat, pasta, salads, etc. Many of these products are packed aseptically on thermoform in fill seal machines. Ethyl vinyl alcohol. Ethyl vinyl alcohol is a copolymer of ethylene and vinyl alcohol. It is related polyvinyl alcohol, which is a water soluble synthetic polymer with excellent film forming, emulsifying and adhesive properties. It is high barrier material with respect to oil, grease, organic solvents and oxygen. It is moisture sensitive and in film form is water soluble. Ethyl vinyl alcohol itself has packaging applications in film form, but not in food products, and is used as coating for biaxially oriented polypropylene. Polystyrene, ethyl vinyl alcohol and polystyrene as well as polystyrene, ethyl vinyl alcohol and polyethylene sheets are used for processed cheese, UST milk and milk based desserts and drinks. It is also used for map of fresh meat and for pasta, salads, coffee and hot filled processed cheese, including portion packed cheese and fruit compote. A high barrier sheet can be constructed with polypropylene, ethyl vinyl alcohol, polypropylene for pasteurizable and retortable products such as fruit, baby food, sauces, ketchup, ready meals, and some of which are heated by microwave. Co-extruded film applications can involve ethyl vinyl alcohol with nylon, LLDPE, and ionomer with food products such as bag-in-box wine and processed and fresh meat. Fluoropolymers. Fluoropolymers or fluoroplastics are high performance polymers related to ethylene, where some or all of the hydrogen atoms are replaced by fluorine. And in the packaging polymer, a hydrogen is also replaced by a chlorine atom to produce polychloro-trifluoroethylene. It is highest water vapor barrier of all the commercially available packaging polymers and is a very good gas barrier and offers high resistance to most chemicals at low temperatures. In many applications, it is suitable replacement for aluminum foil. It is also available as a film or sheet. It is transparent, heat sealable, and can be laminated or thermoformed and metallized and sterilized. It is relatively expensive and is best known as a thermoformable blister pack material laminated with PVC and for pharmaceutical tablets. Food packaging applications are possible but are not highlighted at the present time. Polytetrafluoroethylene, better known as Teflon, has high melting point and inert and waxy polymer. It is used in the form of tape and coatings on packaging machines to reduce adhesion, where that could be a problem such as heat seal bars, and to reduce friction where packaging materials move over metal surfaces. So, friends, in this module we have discussed about different types of plastics and their applications in food system. Thank you.